Right now, in a museum storage room in Baghdad, there sits a small clay jar. It's unremarkable to look at. Cracked. About 5 inches tall. The kind of object you'd walk past without a second glance. But inside that jar is a copper cylinder, an iron rod, and the faint chemical residue of something acidic. Put those three things together in the right way, and you get a battery. Not a metaphor, not a stretch, an actual functioning electrochemical cell. And this one is roughly 2,000 years old. So the real question isn't whether ancient people could build something like this. The real question is why. In 1938, a German archaeologist named Wilhelm König was cataloging artifacts at the National Museum of Iraq when he came across this strange little jar excavated years earlier near the village of Kuyut Rabua, close to what was once the city of Ctesiphon. At first glance, it looked like dozens of other ceramic vessels from the region. Inside the jar was a copper tube sealed at the bottom with an asphalt plug. Suspended inside that tube, held in place by another plug of asphalt at the top, was a single rod of iron. The iron never touched the copper directly. It was isolated, insulated, positioned with what looked like intention. Koenig had spent years studying ancient metalwork. He knew what corrosion looked like on copper that had simply sat in soil for centuries. This corrosion looked different. It looked like something that had been in contact with a mild acid. In 1940, he published a short but explosive claim. This object was an ancient battery. And if he was right, it meant someone in Mesopotamia had built a source of electrical current more than 1,000 years before Alessandro Volta invented the first modern battery in the year 1800. You can imagine how that landed. Here's where it gets interesting. Koenig didn't have the tools to definitively prove his theory, but others tried to. In the 1970s, a researcher named Arne Eggebrecht attempted to replicate the jar using materials and methods available in the ancient world. He filled a reconstructed version with grape juice, an acid readily available in the region at the time, and measured a small but real electrical output. Later experiments using vinegar produced similarly modest currents, somewhere around half a volt to just under 1 volt per jar. Half a volt doesn't sound like much. It won't power a light bulb. It won't run a phone. But wire several of these jars together in a series, the way you'd link batteries in a flashlight, and you start generating enough current to do something. The question that has divided historians and scientists for nearly a century is, to do what, exactly? This is where the story splits into two very different paths, and understanding both is the key to understanding why this artifact remains genuinely unresolved. The first path is electroplating. Ancient Mesopotamian and Egyptian metalworkers were extraordinarily skilled at applying thin layers of gold or silver onto other metals to make them appear more valuable. For a long time, historians assumed this was done through fire gilding, a process using mercury and heat. But some researchers, including physicist John William Kaiser, who studied the jar extensively, proposed something different. What if these jars were used to electroplate metal objects using a small ancient current, essentially the earliest form of electrochemistry, applied for jewelry or religious objects rather than industry? If true, that reframes the entire object. Not a mysterious power source with no explanation, but a specialized tool for a specific ancient craft, hidden in plain sight for 2 millennia because no one thought to test it electrically. The second path is far stranger and far more contested. Some researchers have pointed to the object's shape and placement near temple ruins and its resemblance to devices used in later history for a different purpose entirely: pain relief. Ancient Greek and Roman physicians documented the use of electric fish, specifically torpedo rays, applied directly to the body to numb pain, a practice recorded by the physician Scribonius Largus as early as the 1st century. If Mesopotamian healers had independently discovered that a mild current produced similar numbing effects, jars like this one could have functioned as an early, if crude, medical device. Neither theory has been proven. And that uncertainty is exactly why the Baghdad Battery keeps resurfacing in conversations about ancient technology decade after decade. Because here's the deeper unease this object creates. Historians like to imagine technological progress as a straight upward line. Fire, the wheel, bronze, iron, writing, each step logically building on the last, moving inevitably toward the modern world you live in. The Baghdad Battery doesn't fit that line. It suggests that ancient people may have understood electrochemical principles, even if only through trial and error, without any framework for what electricity actually was. They may have discovered a functional application of a scientific concept centuries before anyone wrote down the theory behind it. That's not as unusual as it sounds. Humans have a long history of using things correctly before understanding why they work. Ancient societies fermented alcohol for thousands of years before anyone understood yeast or microbiology. Willow bark was used to treat pain for centuries before anyone isolated the compound that would eventually become aspirin. Practical knowledge, discovered through observation and repetition, has always run ahead of formal scientific explanation, which raises the uncomfortable possibility that the Baghdad Battery isn't actually a mystery of impossible technology. It might be a mystery of forgotten technology, a functional discovery, developed by skilled ancient craftspeople, used for a specific purpose, and then lost, not because it was too advanced to survive, but because the society that used it collapsed, and the knowledge of exactly how and why it worked was never written down in a way that outlived it. That's the twist historians rarely emphasize enough. Ancient knowledge doesn't usually vanish because it was too primitive to matter. It vanishes because the specific people who understood it die, or are conquered, or move on, and no one thinks to preserve the details, because at the time, it doesn't yet look like something worth preserving. Consider how many innovations from your own lifetime already exist only in the memories of people old enough to have used them, waiting to become someone else's future archaeological mystery. Technology doesn't have to be advanced to be lost. It only has to stop being written down. So when you look at that small, cracked jar sitting quietly in a museum collection, understand what it actually represents. Not proof of ancient superscience, and not an accident mistaken for genius. Something in between. Evidence that curiosity, experimentation, and applied cleverness didn't begin with the modern world. They were already here, thousands of years ago, in the hands of someone who never wrote down exactly what they had built, or why. And that is the real mystery. Not whether ancient people could have built a battery. They clearly could. The mystery is what else they built, used, and understood that never survived long enough to be found. Right now, in a museum storage room in Baghdad, there sits a small clay jar. Unremarkable to look at. But it isn't a mystery because it's impossible. It's a mystery because it's a message from someone who assumed you would already understand.